This is the recording for EDF 1012 on the at-home work on matrices. Now this shouldn't be too long. And I'm looking at the first slide on the PowerPoint that's on Moodle. And what we can see there is there's an example of, it's like a map. It's a network of roads between four towns, A, B, C and D. Now the purpose of this is really just to show you what matrices might be for. But we're not going into much detail about what matrices are for, but they are widely used. And in this case, we can see, for example, if you look from dot A to B on the PowerPoint, there's one road connecting it. If you look from A to D, there are no roads directly connecting it. And if you look from A to C, there are two roads. And of course, there are no roads connecting A to A itself. So if we look at that grid on the right, I can see from A to A there's 0, from A to B there's 1, from A to C there's 2, and from A to D there's 0. And on this particular network, I can see on the diagonal going from top left to down right that in fact there are no A to A's and B to B's and C to C's and D to D's and so on. Not all the towns are connected, but that's really easy for me to read if I want to know, okay, how can I get from C to D? I can look at the row C and the column D and I can see there are three ways of getting there. Or I can look at the map itself. So this is an alternative way of representing that. Now, in the grid, it looks like one thing, but when we put it in the square brackets, as you see at the bottom of the page, that is now called a matrix. Another word for it is an array of numbers. So an array means that we have rows and columns. And that's what we've got here. So I'm moving to the second slide. I haven't done anything yet, but now you can see the matrix there on the page that's on the slide in front of you. And a little definition. A matrix, and notice that the singular is matrix, plural matrices. A matrix is a rectangular array of numbers arranged in rows and columns. Now, inside a matrix, we have elements. Okay, so the matrix that's on the screen now, if you're looking at the second slide, well, it's actually the third slide, has four elements, 2, 0, 1, -4, -1, and 2. Those are numbers. The matrix itself is not a number, but we do operations with it as though it's a number. We do addition and subtraction, we do multiplying with matrices, as you'll see. All right, now, when we define matrices, we need to talk about their order, which is also sometimes called the dimensions. And the matrix in front of you has 3 rows and 2 columns, so we call it a 3 by 2 matrix. That's its order, all right? Or if you like, you can call it, that's the dimensions. Okay, so the blue sentence at the bottom, a matrix with m rows and n columns is called an m by n matrix. I'd like to also point out to you, and this is not on the PowerPoint, that we also refer to individual elements. So we're looking at the little screen now. For example, I'm circling the 1 here. That is in the second row, and that is in the first column. So we call that the 2, 1 element. Okay, that's just a way of describing which element we're talking about. Don't worry too much about that because we're not going to be dealing with very big matrices. Okay, next page, you can see the largest matrix we're going to deal with probably will be a 3 by 3, and we won't do much beyond addition with those. But first of all, we're talking about addition and subtraction of matrices, and the rule is only matrices of the same order can be added or subtracted. And the reason for that is when we add and subtract matrices, we actually add and subtract the elements. And so if they don't have corresponding elements, then they can't be added or subtracted. So all right, so I'm going to show you how I do addition of matrices, and it's very straightforward. I simply take the corresponding elements. Let's start at the top left, the first row and the first column. I take those two, a 1 and a 0. I add them together to get 1. Now I'm going to go to, just a second. Now I'm going to go to my next 2, the 3 and the 2, they are corresponding. They're both in the top right-hand corner. So I'm going to add them together and get 5. Whoops, that got deleted. Sorry, I didn't mean to do that. So I've got 1 and 5. Similarly, I'm going to add these two together, negative 2 and 3, which gives me 1. And then I add 4 and 5, which gives me 9. That's all I do. So now looking back at the screen, the question first of all asks which of the following matrices can be added or subtracted together. Well, I need them to be of the same order because if I try and add things with different numbers of elements, I won't know what to do. It's not the same to have something missing as it is to have 0. Let me show you what I mean by that. If I just quickly draw in this matrix, let's go 1, 2, 3, 4, plus 5, 0, 2, 0. I can add these two together because I can add the 1 and the 5 together to give me 6. I can add a 2 and a 0 together to give me 2. I can add the 3 and the 2, which gives me 5. And I can add the 4 and the 0, which gives me 4. Okay? But what I can't do, I can't add these two together. What am I going to add the 1 to? Maybe I would add it to this 4. Oops. What's that? Maybe I would add it to this 4. Is this corresponding to this row? Or would the 2 get added to the 4? And if the 2 doesn't get added to the 4, then what do I add the 2 to? There's nothing there. So quite simply, I cannot do that because they don't have the same order. So back to the slide. That means that A, C, F, I, and O can all be added. B and G can be added. And D and E can be added or subtracted. Okay, so that's that slide. Go to slide 5. Now it's asking me to actually do some of these additions and subtractions. Okay, so I've copied down the first one, D plus E. So I've got 2, negative 1, 3, 1, 4, negative 2, 2, negative 3, 0. That's D. And E is 2, 0, 0, negative 3, negative 1, 2, 4, 1, 3. All I do, once again, is I add the common elements. So in my first one, I'm going to add the 2 and the 2 to get me 4. Then I'm going to add the negative 1 and the 0, which is going to get me negative 1. Then I add the 3 and the 0, which gives me 3. I add the 1 and the negative 3. Now be careful with your negatives. Adding 1 and negative 3 is going to bring me to negative 2. I add the 4 and the negative 1, giving me 3. I add the negative 2 and the positive 2, which gives me 0. And now my last row, I add the 2 and the 4, giving me 6. The negative 3 and the 1, giving me negative 2. And the 0 and the 3 gives me 3. And that's my matrix finished. Don't worry about the colours. Don't need to use colours. Okay, so that was a big one. The next one, the B and the G, are the 3, 2, that's a 3 by 1 matrix, subtracting a 3 by 1 matrix. So I can do that. So just a moment. Okay, once again, a reminder to be careful of your negatives, especially true when we are subtracting, because we're subtracting B minus G. Once again, I go across my corresponding elements. So if I can start with 3 and the 2. 3 minus 2 gives me 1. Now be careful, 2 minus negative 1. Well, 2 plus negative 1 would give me 1. This is 2 minus negative 1. So I'm actually adding the 1. 2 minus a negative is the same as 2 plus 1. So that's 3. And minus 4 plus 3 gives me minus 1. The last one, I'm adding C and F twice. C plus F plus F. Okay, I've written it out, and notice that I've written F twice because I'm adding F twice. It's just the same. I go across the top and I add my common elements. I'll start at the top left, -1 plus -1 plus -1 gives me -3. Top right, 0 plus 3 plus 3 gives me 6. Bottom left, 2 plus 0 plus 0 gives me 2. And bottom right, 3 plus 2 plus 2 gives me 7. That really is all there is to adding and subtracting matrices. It's just addition and subtraction. Nothing complex about it. Okay, now the next slide does some further addition of matrices, but the reason we're doing it is we're leading into a kind of multiplication. So just a second, let me set it up. Okay, so my matrix I'm starting with, I'm going to call A, and A is 1, -2, 3, 5. It's a 2 by 2 matrix. We'll do a lot of 2 by 2 matrices. So the first task is to add, quite simply, A plus A. So I'll do that. I'm going to get 2, -4, 6, and 10. Nothing complex about that. All right. Now let's do A plus A plus A plus A. Okay, I've written this out in a different way. Rather than write out the 4 A matrices, I've just written the additions inside the elements. So you can see that in order to add A plus A plus A plus A, I have to add my top left element, which is this one up here. I have to do it 4 times, which gives me 4. I have to add this one 4 times, which gives me -8. I have to add bottom left 4 times, which gives me 12. And I have to add the bottom right 4 times, which gives me 20. So basically, what I'm actually doing is this, 4 times the matrix A. Okay? So this is what we need to notice, that when I go A plus A plus A plus A, that's the same as 4 times the matrix A. So in fact, if I were to calculate 4 times the matrix A, I would do it simply by taking this number 4 and multiplying it by each of the elements in the matrix. So let's do an example of that. I'm not changing slides yet. So let's calculate 5A as an example. The matrix A hasn't changed. It's still 1, -2, 3, 5. To do 5A, I have to multiply 5 by all the elements. So 5 times 1 gives me 5. 5 times -2 gives me -10. 5 3s gives me 15. And 5 5s gives me 25. Okay, and now I'm changing slides, because what we've just done is called multiplication of matrices by a scalar. And don't worry about the new word, although you will need to learn that word. You'll see it's in purple in bold. A scalar number is an ordinary number. It's just we use the word scalar to distinguish it from a matrix, because a matrix can be added and a scalar number can be added, and it's not the same thing. I can multiply a matrix by another matrix, or I can multiply a matrix by a scalar number. So we use the word scalar. So to multiply a matrix by a scalar, we multiply every element by the scalar. I've got a little algebraic rule for you there, but the best way to look at it is to follow the example I've just given you, and I'm going to do 2 more. I'm going to do 3A, and I'm going to do -2A. I think I can do 3A just on the page right here. So 3A is going to be 3 1s is going to give me 3. 3 times -2 is going to give me -6. 3 times 3 will give me 9. And 3 times 5 is going to give me 15. Okay, I hope that wasn't too complicated. The -2 is also not complicated, but again, we have to be careful with our negative numbers. So, -2A is going to be -2 times the matrix A, which is 1, -2, 3, 5. So -2 times 1 gives me -2. -2 times -2 gives me +4. And the others will all be negative, -6 and -10. And that's how we multiply by a scalar. In class, we're going to learn how to multiply one matrix by another matrix. It's a little tricky, but basically you need times tables, right? It's just multiplying. So it's not really too complex. You've just got to learn the method. And that will be it for in class this week. So then we'll be able to have time to revisit some of that probability work. And that'll be it for the topic of matrices as well. And that is it for this little movie.